Welcome to Fast Math Solutions on Maths with EJD. In this video, we're talking about expanding the generating function g of x equals 1 over x, 1 over 1 minus x squared. The actual aim is to get the first 6 terms of the sequence represented by this generating function. And this is how we progress. The generating function is given by g of x equals 1 over 1 minus x squared. So we need to understand the sequence this is coming from. So, and one way to do that is this. The denominator, 1 minus x squared equals 0, actually represents, so it represents the characteristic equation of the recurrence relation. Okay, so the roots of this equation, the roots of this quadratic equation, dictate the behavior of the solution sequence. So it means we need to know the root of that particular equation. So in this case, we can then say something like this. We solve the characteristic equation. We solve the characteristic equation, which is 1 minus x squared equals 0. I mean, this can be regrouped to be x squared plus x minus 1 equals 0 to have it in standard form. And if we solve this, right, we're going to get x equals minus 1 plus or minus square root of 5 all over 2. Now, by the very nature of this, right, if you look at, I've talked about Fibonacci sequence under sequences and series a lot. So if you look at it, right, this actually, you have two roots here, which you can say R1 is minus 1 plus root 5 all over 2, and R2 is minus 1 minus root 5 all over 2. Now, you see that these roots are the Fibonacci, golden ratio, which you can call phi, and its conjugate, So one is the conjugate of the other, and its conjugate. So now we have seen a Fibonacci pattern from here. So so that automatically tells us that it has something to do with Fibonacci sequence. Okay. So we can now say that the general solution for the recurrence relation, which is an plus 2 equals an plus 1 plus an. The general solution of this is actually an equals ar1 raised power n plus br2 raised power n. But I mean, the deal is the fact that we have recognized it to be a Fibonacci sequence. That's the main thing. So here now, so since we need the first 6 terms, so we can now say to expand the recurrence relation, which is an plus 2 equals an plus 1 an plus 1 plus an. This is the characteristic thing about Fibonacci sequence, that each term is the sum of the 2 previous terms. So here now we need the following steps. The first step is this. So you start depending on where we want to start from, right? Um, we can start, most of the times you can start with zero, right? So let's start with zero. You can also start with one as you like. So start with A naught equals zero and A1 equals one, okay? So that those are given initial conditions. You could also start with A naught equals one and A1 equals one, as you like it, right? So start with this. These are like initial, they are given initial conditions. They are initial, given initial conditions. So you can start with 0, 1, or 1, 1. So given initial conditions, because I mean, for you to get an plus 2, it means you need two terms to have come already. So now that you have this, you can now go ahead and go for step 2. In step 2 now, you can compute A2. A2, if n is 0, so you have A2 equals A1 plus A naught, okay? And that means that implies that that A2 is equal to A1, which is 1, A2, I mean A naught, which is 0, so that A2 is equal to 1. So you have the third term like that. We are looking for this for 6 terms. So we can go ahead to 3, then you compute A3, okay? So A3, which is A2 plus A1. So A3 now is 1 plus A1 is also 1. So A3 is equal to 2. I mean, that's what Fibonacci sequence looks like. Then the fourth one, okay, let me change this time around. So number 4 now, you compute A4. Compute A4, which is A3 plus A2. So that is A4 equals, A3 is 2, A2 is 1, so A4 is equal to 3. That's, so you have A naught, A1, A2, A naught, A1, A2, A3, A4. That's 5. So we can go to the next step, where we say we now compute A5, compute A5. That's actually like the 6th term. So compute A5, that's A4 plus A3. So A5 is A4, which is 3. A3 is 2. Okay. So A5 is actually 5. So we can go A6 and we can keep going like that. So from all of this now, we can just conclude that therefore this process produces the Fibonacci sequence, the Fibonacci sequence 0, 1, and which is 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, right? So that's what we have generated. So we can keep going, and have maybe things like 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 44, 21 plus 44 is 55, and so on and so forth, okay? That just keeps going like that. So that's the end of this. So you can expect more videos like this. So if you have not subscribed to this channel, be sure to do that right away. And hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are. Let me know if there's a topic you like me to teach or a problem you like me to solve. And like and share so that more people can have access to this great learning. Bye.